Hi, my name is Tim. I'm Senior Application Specialist at ATR Soft. In today's webinar, we will have a look at a very useful function that exists in CustomTools for making simple bench sheets really easy. There will be a Q&A session at the end to let you follow the presentation better. But should you have any questions during the presentation, you can use the chat box in the GoToWebinar panel, and Francois will answer them for you. I expect the webinar to be pretty short, at about 15 minutes. The webinar is being recorded and will be online later today. Okay, let's get started. In the previous webinar, I showed how to clean up a model so it is usable directly in downstream applications like laser cutting. This was a one-button task. If you missed that webinar, make sure to watch it from our archive on CustomTools info. In this webinar, I'll show how you can further leverage your sheet muscle files. You can insert a bending sheet like the one on screen now. This is a very useful view that most of you will create anyway. It is a bit time consuming to do it, so of course CustomTools automate this task for you as well. There is no need to spend time in PowerPoint. Let's get it on. So I'm going to open up this drawing. And from here I can do several things. In the last webinar I showed how we could do the cutting profile. One button click, and I'll do that again just to show you. So this is going to create the DXF sheet for this file where we clean up all the unnecessary lines that is in the DXF file. Now, if we are going to create this part, we probably need to have a bending sheet as well. Some customers are using the insert flat pattern and then they dimension to the bend lines and just use that. Basically, you can do that as well, but we created one simple task. It's called a bend sheet, or a function you could call it. So I'll just click the bend sheet and it's going to create a new sheet for us like we do for the DXF sheet. But in this case, we are going to insert the dimension from the lower left corner and to the extent of the part file, as well as to the bend lines. Now, I don't want to save this drawing, so I'm going to throw that away. And then I'm going to open it up. Actually, I'm going to open up the assembly. Now, from here, I can actually open the part file, and I could run the same operation. So to do that, I need to run it from the print and convert dialog. Now the drawing does not have any bend sheet, nor does it have any DXF sheet, but we do have these tasks that I showed the last webinar, where we can insert the cutting profile sheet. So the cutting profile sheet is going to add a DXF sheet to my drawing. Now additionally, there was a rule selected. The batch conversion DXF from drawings was automatically selected. So now you can see that we selected one task as well as one batch operation. Let me select the create bend sheet as well. So the create bend sheet is going to do the same. It's going to add another task, and we are going to add another sheet to this one. So you can see the cursive text indicates that a new sheet is going to be added and saved on the drawing. One of the things that I've learned using CustomTools is that customers tend to get confused about the selection. Now, we selected two different rules. Why is there only one tick mark in the user interface? Well, that is basically because that applies for that one you have selected. So the create bend sheet is this one with the tick mark. If I select the cutting profile, then this one gets active and has the tick mark. Same applies for the batch conversion. Now the bending instructions has been highlighted, so this is the tick mark that we show. If I select the DXF from drawings, then that is the tick mark I'm going to show. If I select something else, nothing is going to be shown because we didn't select anything. But if I select the DXF from part, it's going to add a tick mark to the part file. So based on what you are highlighting in this list, it's going to show up in here. That was like a small sidestep, sorry for that. But now I can run this conversion and it is going to create these sheets directly onto my drawing. So I'm just going to hit OK and process that. Yeah. So a lot of things is going on right now. We are creating these sheets on the drawing, and we are also batch converting files on the fly. So if I go back to this one and I explore into that folder, we now have a brand new sheet called Bending Instructions, a PDF file. So if I open up that one, I have this ready for print or whatever I need. It's a PDF file. And in the DXF location, created at 10:06, that is right now, I also have a DXF file created of the cleaned up DXF. Looking like that. And we insert a note, as I also showed in the last webinar that we did, the part 1 of 2. So here we can see that it's made of plain carbon steel. It's 8 millimeter. The quantity is 1 because it's run from a part file. And the total cutting length inside and outside is 1544.32 millimeters. So we get a lot of information inserted as well into the DXF file if we want to. Now, I'm just going to delete these ones. So nothing is existing in this location anymore. And I want to open up the drawing for this one and show that we created the DXF sheet as well as the bend sheet. Now I'm going to delete those again. And save the drawing. And save or close the part file. So now you have seen we can run these tasks from drawing, from part, but we can also run it from assembly scope. So I'm going to run the print and convert again. And this time I'm going to create the missing sheets on my drawing. So I'm going to create a cutting profile, inserting the cursive text, highlighting with a tick mark, then selecting the create bend sheet, inserting the bend sheet and showing the tick mark. We are going to run conversion, a PDF and a DXF, but I would also like to create a DXF from the part file. So now I'm going to create one more DXF. So hitting OK. And yes, I would like to continue. This is going through the entire process again, and then it's going to create drawing sheets that are missing and convert the files that I have requested as well. These tools, the bend sheet and the cutting profile, is only applying to sheet metal files. If you have multi-body files, you cannot use those on drawings. Then you need to use them from the part scope directly. So we do support multi-body files, but only from the part or assembly scope. But now I have created some new files. I deleted those a second ago, so now it's 1010, and I have the bend instructions, as we saw before. In the DXF folder, I do have two part files. One is for the part file, or from the drawing, basically, and the other one is from the assembly. So let's investigate the difference between these two. So in this case, it comes from the assembly. I can tell that because I have the quantity of 9. So the assembly knows when we create this that we need 9 instances of this one. And if I look at the other one, it should return only 1. Basically from the assembly, it should actually return 9 as well. Yeah. So these are some of the tools that we offer as well for everyone using sheet metal. Just another info for the node. We can add almost any information you want in this node. If you wanted to have the number of pierce points required to do this part, in this case that would make sense because that would have an impact on your manufacturing process. We could actually count how many holes there are inside, as well as add one for the outside perimeter. So you'll have an accurate representation of all of these holes. So you'll have a number in this node as well. If I go back to CustomTools and then open up the options just to touch that very quickly. The cutting profile options I already covered in the last webinar. In this one, we looked at the bend sheet option. So you can create a new sheet with any name you want. In this case, I'm using bend sheet. You can define if you want to use a note template to insert on your bend sheet. You can define which sheet format you want to use. Is it going to be the same as the first? Should it be selected based on the first sheet? So you can do some mapping that if you are using this type of first sheet, then you should use that for your bend sheet. You could use a standard where you define any type you want, or you could use a custom and even add a completely different sheet for your bending instructions. You can select to show or not show the sheet format, and you can prompt when it's not run as a task what you want to add as a format. We also have options to control the bend nodes as well as bend lines. And then we have this small thing going on down here. When we run this as a task, what should then happen? Well, we want to save the drawing after the sheet is added, most likely. And then we can select 2 additional things that is going to happen when we run it from the print and convert dialog. We can print to a profile, and we can run a file conversion. So you can have the task create the bend sheet, you can print it, and you can convert it with just one tick mark in the list. For everything else in the file conversion, if I look at the bending instruction, I have set it up so that if the sheet name contain bend sheet, then it's going to process this one. And I can then define what I want for the conversion rule itself. Okay. That is actually all that I had to show for you today. The next webinar is called Understanding the Action Group and will be held June 7th, same time as today. Here I will show a few hidden functions that you may not know exist in CustomTools, but you will realize that those are functions you cannot live without. I am open for questions when the recording is stopped, but first I want to thank you for attending this webinar, and I hope to see all of you for the next one. Thank you and have a nice day.
We are in the life-saving business. We kill your routines before they kill you.